Hey guys, good morning. So here is the video for the class for today. We would start by walking you through the homework problems for chapter 4. Remember, the homework problems have been assigned and I believe they are due next Monday. I think so. Yeah, but the first thing you want to do is solve this problem. So let's go through them one after the other. Let's start with number 15 here. Number 15, you have a particle that leaves an origin with an initial velocity v equals 3 I hat and constant acceleration a equals negative 1 I hat minus 0.5 j hat meters per second squared. When it reaches its maximum x coordinates, what are its A, velocity, and B, position vector? So remember what we're doing in chapter 4. In chapter 4, we've taken everything that we've studied in chapter 2 and we are rewriting those quantities using as vectors, using what we've learned in chapter 3. So for this first problem, why don't you write down the things that we know, the values that we have been given. So we have initial velocity v naught equals 3 I hat meters per second. And then we have the acceleration equals negative 1 I hat minus 0.5 j hat. That's meters per second squared. This is meters per second. Okay, what else do we know? Those are the only values given, but we're looking for the velocity and position vector when it reaches its maximum x coordinate. That's telling you something. At maximum x coordinates, what is our v, final velocity? When it reaches the maximum x, then it cannot go anymore. So if the particle cannot move anymore, that means the velocity is 0. So final velocity will be 0 at maximum x, so that our v, final velocity in the x coordinate, will be equal to 0. So remember, for these problems, we can solve component by component. So let's solve along the x direction. Along the x direction, you want to find velocity at, okay, you want to find velocity. One of the things we need to know is, what is the time? How long did it take the particle to reach its maximum x coordinate? So you can solve that for along x direction. But let's write some of our equations along the x direction. One of the equations would be x, and these are some of the equations of motion at constant acceleration that we were introduced to in chapter 2. So x as a function of time will be equal to v naught x t plus 1/2 ax t squared, right? And then another one of those equations, vx, will be equal to v naught x plus ax t. So this is from the first equation, v equals v naught plus a t, all written for the x. Along the y direction, let's write the same equations for the y direction. Along the y direction, y as a function of time equals v naught yt plus 1/2. This would be ay, right? Ayt squared. And then we can write for the first equation along y, vy equals v naught y plus ayt. All right, cool. So let's find the first velocity. First let's find the time. To find the time, we can use this equation. Let's rewrite this equation. Final velocity Vx equals V naught x initial plus Ax t. So final velocity at x, we know that it's equal to 0. So we rewrite this as 0 equals, what is V naught x? Remember, V naught is 3I hat. So if you don't have anything for the j hat, it really means that it's 0 j hat. But our V naught x will be 3 because on our V naught, the 3 I hat points in the positive x direction. So this will be 3 minus, or plus, what's our ax? You look at the acceleration vector, the x component of it is -1. So that would be, our ax is -1 multiplied by t. So you really have 0 equals 3 minus t. And from this, you can find your time. Your time equals, just rearrange this, and whatever time is, you put it in here. So now that you know the time, this is the time that it takes the particle to reach its maximum x coordinate. So you can find the Vy. Remember, Vx is the final velocity along the x coordinate, and then your Vy will be equal to, use this equation right here, V naught y plus a t. You already found your t above here, so plug in this value of t here. This V naught y plus a, this should be ay t. Plug in the value of your ay from here. This is the y component of your acceleration. What's your V naught y? Your V naught y is 0. You plug that in from here. And from this, you can calculate your Vy. So your Vy equals, you get another answer. So that for the A part, the velocity at maximum x coordinate, your V will simply be equal to the V final velocity in the x I hat plus final velocity in the y j hat. And that would be your answer for the first part. And then B, position vector. How do you find the position vector? All right, for the B part, the Position vector, we really just need to find your R. Your position vector will be equal to the X I hat plus Y J hat. And remember, you're finding all of this at time t, which the time t you find it earlier there. So now you just need to find your X I hat, and your X I hat, that's the X part of the position. You find it using this equation right here. Yeah, this equation. So let's write the equation down. X I hat will be equal to V naught X T plus 1/2 AX T squared. So let's plug in the values. What's your V naught X? Your V naught X is 3. So this is your V naught, and this is the X part of it. So that's 3 multiplied by what's your time? Whatever time you got here, you put it in here. You already have a value for that. Plus 1/2 AX. 1/2 multiplied by your AX is -1 multiplied by the time that you obtained the square. So you have the time, and you can just multiply it through and get an answer. And then likewise, you do that for you get some answer here, and then you likewise do that for y as a function of time, and this is when time was equal to whatever time you get here. You write your equation V naught y plus ay V naught yt plus half ay t squared. You plug in your values. Your V naught y would be your y value of V naught, which is 0. T is whatever value you obtain here. Ay would be your negative 0.5. That's the y component of the acceleration. And your t would be this. So you just square the value you get here. You plug in all those values and you solve. And when you finish solving, so here you get an answer for this. Here you get another answer for this. This answer here will come into the X I hat. This answer here will come into the Y J hat. And that's how you write your position vector. You're going to write your answer as R equals whatever answer you get from the first one, I hat, plus whatever answer you get from the second one, J hat. I hope that's enough hint for you to solve that problem. All right, let's move on to number 25. Okay, to move on to number 25, I'm going to have to erase the board. So I'm going to clear all of this. Let's clear it. All right, number 25. The current world record motorcycle jump is 77 meters, set by some dude, Jason. Assume that he left the takeoff ramp at 12 degrees to the horizontal and that the takeoff and landing heights are the same. What is his takeoff speed if you neglect air drag? So this is interesting. I think you should draw a diagram here. So what does the diagram look like? You have Jason here riding a bike. Let's not take too much time drawing the bike, although it's kind of fun to draw the bike. All right, so it takes off from, say it takes off from here at an angle 12 degrees to the horizontal. Your x direction is the horizontal, so it takes off 12 degrees. It takes off with some initial velocity. The angle here would be 12 degrees, so v naught. That looks like a projectile motion, doesn't it? Of course it is. So what do we have? We have so it was able to jump over 7 meters. That would be your range. So from the takeoff position to the landing position at the same point on that axis is your range. So R equals 77 meters. All right, what else do we have? I think that's all that we're given. Of course, we know that G, acceleration due to gravity, G equals 9.8 meters per second squared. All right, so how would you solve this? When you think about it, you have the range, but you need to find its takeoff speed. You need to find v naught. So you have range, you need to find v naught. V naught equals or none. So again, using the steps that we learned for solving problems, first we drew a diagram because we thought it was necessary. Next, we have written down all the values that we've been given. Oh, theta, we're also given theta equals 12 degrees. And then we've identified the value that we need to find. Next, we have to write an equation that has all these quantities, and then we can rearrange if possible. Then we plug in the values, we punch a calculator, and we find our answer. We have to rearrange if necessary. So what do you guys know? Don't you know the formula for the range? Yes, you do. So range equals, what's that formula? V naught square sine 2 theta divided by G. So if you look at this equation now, you have your range, you have your theta, you have your G. The only thing you don't have is V naught square. So if I were you, I will rearrange to make V naught the subject of the formula. That will be the first step. And then the second step is plug in the values. Then calculate and write your answer in answer plus unit. Okay, so that's it. I'm not going to rearrange this for you. I think by this time every one of you should be able to rearrange. You know, to rearrange that, you just want to make your V naught only on one side and everything else on the other side. So work on that, and that will give you your answer. So that's all the hints I have for you for number 25. Next, number 30. I'm about to erase this. All right, some of you are wondering, how would you rearrange this? Of course, everybody should know that. But if I were you, I would do this R divided by 1. I would do cross multiply so that your V naught square sine 2 theta will be equal to G multiplied by R. And then after that, I would divide both sides by sine 2 theta. So this cancels this, you are left with V naught square. But remember, you need to find V naught, not V naught square. So to find V naught, you can just take the square root of both sides. So the square root will cancel out the square. And then you're left with your V naught. All right, that's way more hints than I planned to give. Good luck with the rest. As always, reach out to me if you have any questions. Okay, let's move on to number 30. I'm gonna erase this. All right, number 30. Someone is playing some really cool sport, right? A soccer ball is kicked from the ground with an initial speed of 19.5 meters per second at an upward angle of 45 degrees. Let's draw that. Let's draw our x-axis. Okay, so start from the origin. This soccer ball is kicked with an initial speed, so v0. So it's kicked, your angle is 45 degrees, so that's the angle your v0 makes. So that's your v0 right there. Do we have a v0? Oh yeah, v0 initial speed is 19.5 meters per second. Okay, do we have the range? No. But so this ball, we have drawn it to be kicked in the x direction. It's the path is parabolic, so this is a projectile. Now a player 55 meters away in the direction of the kick. So the direction of the kick is in the positive x direction. There's a player 55 meters away. Let's place our player here. That means from this origin to where the player is 55 meters. You guys see that? All right. So this guy starts running to meet the ball at the instant. So he starts running in this direction. So the question is, what must be his average speed if it is to meet the ball just before it hits the ground? So this guy wants to run and he wants to get here at the same time that the ball gets here. So the question is, what must be his average speed? So how would we find its average speed? We know that speed equals distance divided by time. Okay, so if we can find the distance and we can find the time, then we can find the speed. Now think about it. The distance that this guy will cover is the distance from where he is to where the ball is. And this will be this distance right here. Let's call it D. All right. So what you need to realize is that your distance will be equal to the distance from where the ball was kicked to where this guy is, which is 55 meters, minus the range, right? The range of the ball. You know, the ball starts from here and it lands here. So if you take this range from all the 55 meters, then you get this distance. All right, cool. So we can find our distance. Then how do we find our time? For this guy to get to the point, to the position where the ball lands at the same time that the ball lands, that means the time for the guy must be equal to the time it takes the ball to land at that position, right? So if you can figure out the time that it takes the ball to get to that position, then you can find the... So there are two ways to do this. One, you can use one of those equations of motion at constant acceleration that we have, and that's the equation that says x minus x naught equals v naught x, v naught t plus half a t squared, right? So I think that one of them says x minus x naught equals v naught v naught plus 1/2 at square, right? I think it's v naught, x minus x naught equals v naught t plus 1/2 at square, yeah. So now let's write this equation for the y direction, right? Remember, the beauty of projectile motion is we can take any equation and we can write for the x direction or the y direction at any point in time. So let's write this equation for the y direction. Y minus y naught equals, this will become v naught y t. For the y direction, what's a? Remember your a is negative g, so this will become minus 1/2 gt square. Guys, if you solve this problem, let's plug in the values and we'll see that the only unknown value is t. So from this we can find our t. Y minus y naught. Y is the final position on the y-axis, which is 0. Y naught is the initial position, because if you look at the y-axis, it starts from the origin and it gets to the highest point and then it comes back. So y minus y naught is equal to 0 equals, this would be v naught y. Remember, v naught y is v naught sine theta. We talked about this in the last class. So v naught sine theta t minus 1/2 gt square. Let's plug in the values. 0 equals, what's your v naught? It's 19.5 sine of 45 degrees t minus 1/2 multiplied by 9.8 t square. So if you solve this, you will get you have, oh, actually you can rearrange this, bring all of this to the other side, and it becomes 1/2 9.8. So 1/2 times 9.8 t equals 19.5. You can do sine 45 and then multiply by t. So one of them should be t squared. This is t squared. So this 1t cancels this 1t, and you can rearrange this to make this t on one side. So your t will be equal to 1/2 of 9.8. I think you guys can do that. That would be 4.9, I believe. So this 4.9t on one side, divide both sides by 4.9. So your t will be equal to 19.5 sine 45 divided by 4.9. You solve that and you get an answer for your t. Okay? So now that you have your t, you can now rearrange this for x minus x naught just to find the range. So you can either use x minus x naught equals v naught x t plus 1/2 ax t squared, right? And you plug in the values. Your v naught x is v naught, no, for x it will be cosine. So v naught x will be v naught cosine, oops, select this, okay, v naught cosine cosine theta, yeah, t. And then for the ax, remember the projectile does not have any x acceleration in the x, so all of this just simply becomes 0 plus 0, because ax is 0 multiplied by everything else just becomes 0. So you can plug in this. You know your V naught is 19.5. How do you take this away? Guys, I don't know how to work this. Okay. Oh, cool. All right. So your V naught is 19.5. You plug it in here. Cosine, your theta is 45. You plug it in here. And then you multiply it by the t that you obtained from the first part. And that will give you your x minus x naught. So your x minus x naught equals range, which is is the, yeah, x minus x naught equals range. So your distance that you need to solve this distance over time will be 55. So your speed will be equal to the distance, which is 55, minus the range that you got when you did x minus x naught, divide by the time that you found earlier. That will be your speed. So you guys should be able to solve that. Cool. All right, last but not the least, number 47. I'm gonna clear this. Number 47 is very interesting. This might take you some time to actually solve it, but it's very important that you understand what's going on here. So of course we need to draw a diagram. A batter hits a pitched ball when the center of the ball is 1.22 meters above the ground. The ball leaves the bat at an angle of 45 degrees with the ground. With that launch, the ball should have a horizontal range. That means returning to the launch level. Remember, that's important for the definition of range. So the ball should have a horizontal range of 107 meters. First question, does the ball clear a 7.32 meter high fence that is 97.5 meters horizontally from the launch point? B, at the fence, what is the distance between the fence top and the ball center? All right, I'm gonna help you to analyze this as much as possible, and then you guys will solve it. Of course, we have to draw. Let's think about this. This is the batter. He has a bat in his hand, and then he hits this ball when the center of the ball is 1.22 meters above the ground. So this batter is standing on the ground, of course. So the position of this ball right here, this distance is 1.22 meters. All right. So this guy hit the ball here, and let the ball go like this. Okay. Now for the range, I think you're given the range, the horizontal range. Remember, the range is, you have to draw your horizontal x direction at the position where the ball leaves to the same position where it lands on the x direction. So this would be your horizontal range, and that's 107. Range equals 107 meters. What else do you have? You have your angle theta. Theta equals 45 degrees. Do you have your initial velocity? No, you do not. Okay, so now the question is, does the ball clear a 7.32 meter high fence that is 97.5 meters horizontally from the launch point? So from this launch point here, you go 97.5 meters, and then right here there's a pole, there's a fence, and the fence is 73.2 meters high. So let this be the height of the fence. not. Let that be the fence. The fence is 73.2 meters. The distance from here to here, 73.2 meters. That's the height of the fence. Now the question is, does the ball clear this fence or not? And then the second question is, what is the distance between the fence top and the ball center? Let me tell you what the question is asking. Does the ball clear the fence? If the ball clears the fence, that means the ball goes like this and goes over the fence. So if the ball clears the fence, the second part is, what is the distance between the fence top and the ball center? What is this distance? Okay. If it clears the fence, then this will be your D. But what if it doesn't clear the fence? If it does not clear the fence, then it will look like this. The ball will start from here and go and hit the fence. So if it doesn't clear the fence, you have to find this distance also. D. All right. I hope you understand what you need to do now. The question is, how do we know if the ball clears the fence or not? Oh, how do I change this color? No, that's not it. How do I change this color? Let's try that. Does that work? Let's select this. Oh. That should change it, right? No, it doesn't change it. Come on guys, how do you change this? Okay, I think we've changed it. No. All right, let's stick with blue. Sorry, I don't know how to work this. All right, so what are we doing? Does the ball clear the fence? This is how we know if the ball clears the fence or not. I'm going to draw this again, this time a little bit bigger. The ball starts from right here and it goes, this is where the fence is. What we need to find is, one, can we find the time where the ball flies over the fence? What's the time at this position? T. If we are able to find that time, so meaning what's the time when the ball has traveled a distance of 97.5 meters along the X axis. Remember, the pole is located at 97.5. So first, okay, so we need to find that time. And if we find that time now, we can also find the height of the ball at this time. So what's the height of the ball from here on the y-axis? What's this height at this time? If you find this height, we can add this height to the height of the player to determine the height from the floor of the ball. And we just compare that height to the height of the wall. And then if this whole height is more than the height of the wall, then that means the ball clears the wall, the fence. But if the height is smaller than the height of the fence, that means the ball did not clear the fence. Okay, so how do we find t? We can, I believe we can find initial velocity because we know we're given the range. Remember, the range is equal to 107 meters. So using the range equation, r equals v naught square sine 2 theta divided by 2g. If you rearrange for v naught, just like we did in problem number 30, your v naught will be equal to square root of gr divided by sine 2 theta naught. Plug in the values and you do your calculation and you should get, actually I'm not going to tell you, you guys should get an answer. So you're going to get an answer, boom. Now when you get the answer, next you want to find the time when ball gets to the fence, gets over the fence. How will you do that? You can do x minus x naught analyzing for the x direction equals v naught x, which is simply v naught cosine theta t plus 1/2 ax t squared. But remember, ax is 0, so all of this goes to 0. So x minus x naught is simply your 97.5, the distance to the wall. So your 97.5 meters equals, you know v naught because you found it here. You know your theta because you are given, your theta is 45 degrees. And then you know, oh, we don't know time, but we know v naught, we know cos theta, and then time is the only thing we don't know. So you can rearrange this equation to find time. V naught cosine theta time. Rearrange to find time. And your time should look like something like 97.5 divided by v naught cosine theta. Of course, you know v naught, you know cosine theta, so you plug in the value. And now you have found the time that your ball gets here. So if you do, to find the height of the ball, you can do, what should I use? You can do your y minus y naught equation equals v naught y plus 1/2 ay t squared. So your y minus y naught will be equal to your v naught y is v naught yt, I believe. V naught y is v naught sine theta multiplied by t, and then your a, remember on the y direction, your a is negative g minus 1/2 g t squared. All right, looking at this, what do you have, what don't you have? You need to find your y minus y naught at the time when the ball gets here. You already know the time from the last thing you solved, so that's your time. So y minus y naught equals v naught. You know v naught because you found it here. You know theta, you know t, you know g, you know t, you do t. So you can solve and get your y minus y naught. The y minus y naught you obtain here would be this height. Don't forget, would be this height from the launch the launch position all the way to the point where the ball is. So for example, if your y minus y naught, I'm not going to tell you, you guys have to figure it out. But if your y minus y naught is, if your y minus y naught is, let's say it's 5, okay, that's just, so if your y minus y naught equals 5, if, so don't go write this and think that's the answer. If this is 5 meters, then that means the position of the ball at that point will be 5 meters. So the ball will be 5 meters plus the height of the guy from the ground. So if this is 5 meters, then that ball will be 5 plus 1.22 meters. So that means all of this will be 1.22. So 5 plus 1.22 will be 6.22. So this is what you will compare with the height of the fence and vice versa. Okay, so, and then the B part, at what distance? You just subtract whatever height you get from the floor from the height of the fence. All right, I hope that helps to solve all of these homework problems. So I'm going to stop this video here. If I have more time later, I would make another video to introduce you to chapter 5. But if not, this should be enough for the class. Thank you.